Okay, so what questions we had from the homework that we'd like to look at? I could do a couple of them on the board before we move on. Sorry? Exercise 15, number 9. See if you dictate it. Let me see if I could write it on the board directly. 3 and 9 over 16 multiplied by 4 over 9. Right. All over. 2 plus 6. 6 and 1 over 4. 6 and a quarter then. Right. Plus 1 and 1/5. The whole thing or just multiply here? By 1 and 1/5. And all over like that, right? Is that looking like it there? Okay. Well, what we do here is, first of all, I want you to recognize that this over sign here means that we have to actually do the top, do the bottom, and then the result, we work it from there. Okay? So this over sign here means we have to do the top, then the bottom, then we combine the working out. All right? So let's see what happens. Let's do the top part. Right? So let's work out 3 and 9 over 16 multiplied by 4 over 9. Let's do that part first. Okay? So this here is 16 by 3, which is what? 48. Right? 48 plus 9 is 57. Right? So 57 over 16 multiplied by 4 over 9. Are there any common factors between the 4 and the 16? Right, so 4 could go into 4, 1. 4 could go into 16, 4 times. What about the 57 and the 9? Anything there? No, there's nothing there. So what we will do next is simply multiply the numerators. So 57 by 1 will be 57. And 9 by 4 is 36. Okay? So that would be this part at the top. What about the part at the bottom now? This part at the bottom would be 2 plus 6 and a quarter by 1 and 1/5. Afternoon. Okay? Now what we do here is we do use BODMAS and realize that we have to multiply the 6 and a quarter by the 1 and 1/5 first. So we say 4 by 6 is 24 and 1 is 25. So this is equal to 2 plus 25 over 4, right, multiplied by 5 ones are 5 and 1 is 6 over 5. Okay? So right here we look to see what is factors that could cancel out. So we say 5 and a 5, 1. 5 and a 25 is 5. Okay? Then what else could happen here? 2 could go into 4, 2. 2 could go into 6, 3. Anything else? There's nothing else. So therefore, this will be equal to 2 plus 5 by 3 on top, which is 15, over 2 by 1 below, which is 2. So we end up with 2 plus 15 over 2. So let's work that out by saying, if that is, put that over 1. And we say LCM of 1 and 2 is 2. 1 into 2, 2, 2 by 2 is 4. Plus 2 into 2, 1. 1 by 15 is 15. And 4 plus 15 is 19 over 2. So now, what do we have? We know that the top part is this, and the bottom part is this. So what can we do now? Therefore, we could work out what 57 over 36 over, right, because this is over now, the bottom part worked out to be 19 over 2. Okay? So this is really equivalent to 57 over 36 divided by 19 over 2. That will be equal to 57 over 36 multiplied now by the inverse of 19 over 2, which is 2 over 19, like this. So that works out now to be 2 could go into 2 one time, 2 could go into 36, 18. I think 19 could go into 19 once, and it could go here how many times? 3 nines are 27, 3 ones are 3, 4, 5. So it could go into here 3 times. Then what happens next? The 3 multiplied by the 1 on top will give us 3. Oh, let's over 18, but I could divide it down further, right? I could say 3 into 3, 1, 3 into 18, 6. So the answer here will be 1 over 6. How that went? Good? Okay, we have any other questions? Number 10? Okay, so we're going to work out number 10. We're going to work out number 10 now. All right, we're going to work out number 10. All right, so tell me what number 10 said. 5 over 9 minus 7 over 15. 1, 5, all over 5 multiply by 7 over 15. Like that? That looking correct? Okay. So, what do we do now? Same strategy. You have to work out the top, work out the bottom. Okay, so if we work out the top here, let's work out this first. 5 over 9 minus 7 over 15. Good. So, LCM here of 9 and 15. Let's use here 45. So 5 into 45 is 5. 5 multiplied by 5 is 20. 5 minus 15 into 45 is 3. 3 by 7, 21, correct? So this works out now to be 25 minus 21, which is 4 over 45. 4 over 45. That'll be the top one. The next one we could look at will be the bottom one, which is 1 minus 5 over 9 by 7 over 15. Okay? There's a common factor here and here. So we could say 5 into 5 is 1. 5 into 15 is 3. Good? No other common factors. So we could write this as 1 minus 1 by 7 is 7. 9 by 3 is 27. So you get 1 minus 7 over 27. But we cannot do anything with this here unless we convert it into a fraction. Right? Now, there are other ways, but the most basic way is to put this over 1, like this, and then find the LCM of 1 and 27, which would be 27. The next step is to say 1 into 27 is 27. 27 by the 1 on top gives me back 27. This minus comes down from the top there. And 27 into 27 is 1. 1 by 7 is 7. So this ends up being 27 minus 7 which is 20 over 27. 20 over 27, and that's the bottom part. So now we end up with the same thing. The top divided by the bottom. Therefore, the top is over 45. And you have to divide that now by the bottom, which is 20 over 27. Right? And we know if we have 4 over 45, and we have to divide it by 20 over 27, it's the same thing as saying 4 over 45 multiplied by 27 over 20. So that works out to be, let's see what happens. We could say 4 into 4, 1, 4 into 20, 5. Then we say 9 into 27 is 3, 9 into 45 is 5. So therefore, if we multiply 3 out on the top, 1 by 3 gives us 3, and 5 by 5 gives us 25. So that looks like the answer there, 3 over 25. Okay? Any other question? You want to look at? Okay. Right? That one? Sorry. Right, you could call it out in the meantime. A quarter divided by open brackets. What? Like that? That's correct? Okay. So, what do? We use BODMAS. Okay, so we start off with our BODMAS. BODMAS. And what does BODMAS say? BODMAS says we do what is in brackets first. So we come here and we work on that. Right, so we put the quarter divided by, and we come here and work what is in brackets. Now, if you observe, this 2 into 2 is 1, 2 into 8 is 4. Right, so you could then say 1 by 1 on top will give us 1, over 4 by 5 on the bottom is 20. Right? Now, for a quarter divided by 1 over 20, that brackets doesn't make any difference there because there's nothing more to be done in there. So a quarter divided by 1 over 20, 1 over 20 is equal to a quarter multiplied by 20 over 1, like this. This will be equal to 4 into 4, 1. Hi, 4 into 20 is 5. And then you say 1 by 5 on top is 5. 1 by 1 is 1 below. So the answer is 5 over 1, or simply 5. They give you back the question as the answer. Okay, so what you find is that the exercise book, sometimes the answer is not correct. I would say in this book, maybe about 90% of the times the answer will be correct. The rest of the times it wouldn't be. And you have to be able to say, well, right, this is right and this is wrong. Right, based on your understanding of what is going on. Okay? Any other question to work on? Number 3? Okay. Okay, what does number 3 say? 1 and 2/3. Like this? Is that it? Okay. So, work what is in brackets first. That's what Budma says. Brackets first. So this will become, and what we'll do here is we'll change the number on the left-hand side to to improper fraction one time. So you have 3 by 1 is 3 and 2 is 5 over 3. And we're going to divide that by, let's work out what happens in here. This becomes 3 over 5 multiplied by 10 over 9. Good? So this part on top here, you could do some division. You could say, you could do some cancelling. 5 into 5 is 1. 5 into 10 is 2. 3 into 3 is 1. 3 into 9, 3. So therefore, this here could work down to be 5 over 3 multiplied by 1 by 2 is 2. And 1 by 3 is 3. Did we invert it here? Right, okay. So you're right. So this here is division by 2/3. So it's supposed to be multiplied. So this should still be division there before we work it out. So here, this is still division. Right? And then we would invert after. So it would be 5 over 3 multiplied by 3 over 2. And then we look at what could cancel. 3 into 3, 1. 3 into 3, 1. So you end up with 5 on top. 5 by 1 is 5 and 1 by 2 is 2. So you end up with 5 over 2. Right? But normally when you end up with an improper fraction like this, right, what do? We convert it to a mixed number. So to convert 5 over 2 to a mixed number, you say 2 into 5 is 2 2s are 4 and 1 remainder to make the 5. So it will be 2 and 1 over 2. 2 and 1 over 2. Okay? Okay, that's okay. Any other questions? Taking off this, right? Any other questions with respect to the homework? Okay, no more? That's it? Okay. Okay, so we had left off in the last class in decimals, we had left off at the point of division. So today we're going to start off by looking at how do we divide decimals, right? Decimal fractions. So the example we're going to look at is 0.54125 divided by 0.125. Right? 0.54125 divided by 0.125. Now, this could also be written as 0.54125 over 0.125. Right? It could be written like that. Now the first step is to take the denominator and to express it as a whole number. Right? That is without any decimal point. So let us change this to a whole number. In order to change the denominator to a whole number, we have to multiply it by 1,000. Okay? So this multiplied by 1,000 means move the decimal point 1, 2, 3 places to the right. Okay? So it will become 125 below. And if we move the decimal point 3 places to the right, that is, we make it 125, which is equivalent to multiplying by 1,000. We also have to do that on the numerator as well. Okay, so this will become 1, 2, 3. So that will become 541.25. Right? That's what we have to work on. 541.25 divided by 125. How do we do this now? We construct a division sign like this, and the number on the top goes inside. So the 541.25 goes on the inside, and the number below goes on the outside, which is the 125. Okay? That's what we have to work out. Now, if we had to do this in an exam in the multiple choice section, then we cannot use a calculator. So we have to know how to do this without a calculator, because they could ask you this in a multiple choice. Okay, so the first step we do is write down some figures. Let's just write down 125 by 1, that's 125. Then the next one in line is 125 by 2, 250. 125 by 3, 375. 125 by 4, how much? That's 500, right? And then 125 by 5, that's how much? 625. Now why are we writing down that? Because we have to be able to see how many times 125 could go into this number here. So let's start off. 125 into 5 cannot. So I'll just put a dash there. Then 125 into 54 cannot still. So you put another dash. 125 into 541. So we come here and we look to see which one it could go into it. Which one you'll select? 4. Right? Because 125 by 4 is 500. So you could go 4 times. So you write the 4 here. And then you say 4 multiplied by 125 is 500. So you write it back underneath here like this. Good so far? Then you subtract it, and you get 41. Good? But the thing about division is that wherever the point is, we have to move that point up. Okay, we have to move it up and place it in that position there. Then we say 125 into 41 cannot, so we're going to bring down the 2. So we have 412, and you say 125 into 412, we come back here. Which one? 3. So we put the 3 here. 3 times 125 we know is 375. So we write it here. 375. Okay? Then we say 5 from 2 cannot. You borrow from the 1. This becomes 0. 5 from 12, 7. 7 from 0 cannot. Borrow from the 4. It becomes 3. Carry over the 1. That's 10. 7 from 10 is 3. 3 from 3, 0. So you have 37 there. But 125 can't go into 37, so you bring down the next available number, which is a 5. So you get 375. So 125 into 375 is 3. 3. So 3 by 125 is 375, which works out to be 0 here. So your answer is 4.33. The answer there is 4.33. Yes, this is long division. We're doing two things at one time. We're doing long division, but also we're learning how to divide decimals. In order to know how to do decimals, division, you have to know long division. Okay? Alright, so that is the procedure there that you go through to get this division done. Any questions? No. You always multiply the bottom number by a number such that you make it into a whole number. Right? So if this was 12, you'd multiply, sorry, if it's 0.12, you'd multiply it by 100. Right? And then you'd have to multiply the top by 100 too, and so on. Whatever you multiply the bottom number by, the top number you multiply by the same thing. Okay? And also to remember, the top number here goes inside of the division, and the bottom number goes outside. So in this case, the 541 went inside, and the 125 remained on the outside. Okay? Okay, so the next thing we're going to look at is mixed operations, right? Where we mix up some operations but with decimals. So the one we look at is 0.125 minus 1.56 multiplied by 0.23 into 1 plus 0.46. Right, that's the one we're going to look at next. Okay, so in this question, you apply BODMAS as we were doing from before, and that means that we must do what is in brackets first. Without even putting pen to paper, could you tell me what is 1 plus 0.46? 1.46. You don't actually have to go and add up that. You could see that manually. So this here will be the same thing as saying 0.125 minus 1.56 times 0.23, 1.46 in brackets. Okay, because that's straightforward. You don't need to go and put pen to paper to get that done. Okay, so what's the next step after that? Well, after what is done in brackets, in BODMAS comes division, right? It's of, but there's no of statement, so then you look for division, and there's no division here, so then we must do the multiplication. Now there's a multiplication sign understood right here, right? There's a multiplication sign right there, good? And there's one here. So what I will choose to do, you could do it in reverse if you wanted, but what I'll choose to do is multiply these two numbers together, which is the 0.23, I'm going to multiply it by 1.46 as the next step. Okay, so we could write it here. You could write 0.23 multiplied by 1.46. Okay, so that'll be the next step, 0.23 times 1.46. And if you recall, how do we do this? We multiply by the leftmost digit, which is 1 in this case. If we multiply by 1, then we look to the right and see how many digits there are. There are 2 digits. So therefore, how many zeros do we have to place? 2. So we place two zeros. 1, 2. Then we start to multiply. 1 by 3 is 3. 1 by 2 is 2. So that's what we end up with in the first line. Then we go to the next number, which is 4, and we're going to multiply 4 by the numbers on top. But before that, we have to place zeros. And the number of zeros is equal to the digits to the right of the 4. The number of digits, which is just 1. So we place 1 0, and we start to multiply. 4 by 3 is 12. We cross the 2 and put it here. 4 by 2 is 8, and 1 is 9. Put it there. So we have 2300, and we have 920 so far. Then we multiply by 6, which is the next one in line. But there are no digits to the right of the 6, so you don't have to place any zeros. You say 6 by 3, 18. You cross the 8, put it in place. 6 2s are 12, and 1 is 13. So you write that in there. Okay? So then you add 8 and 0 is 8. 3 and 2, 5. 9 and 1 is 10. And 3, 13. Cross the 3, put it there. 2 and 1 from the 13 make 3. So it's 3, 3, 5, 8. But where do we put the point? The point starts off at that position, to the rightmost position, and you have to move the point according to the number of decimal places on top. So on the top number, you have 2 decimal places, and on the one right below it, you have 2 more. So in total, you have 4 decimal places. So you have to move this point 4 places to the left. 1, 2, 3, 4. So what that does is create the number for you, which is 0.3358. 0.3358. So that means that in the problem that we work in, it will become 0.125 minus 1.56 by 0.3358. Right, 0.3358. So the next step, of course, would be to multiply these two numbers. Right, we started off by multiplying these, then we go down to the next level here. All right, now, first of all, if we write back what we have, 0.125, we multiply a minus number, which is minus 1.56, by a positive number, which is positive 0.3358. Right? And we learned that if we multiply numbers whose signs are different, the result is negative. So we know we're going to end up with a negative number. But we still have to do the multiplication. 1.56 times 0.3358. So if you write it here, 0.3358, and we multiply that by 1.56. Okay? So let's see what that comes out to be now. We place zeros equivalent to what is after the 1. There are 2 digits, so we're going to place 2 zeros, and we multiply by the 1. 1 by 8 is 8. 1 by 5 is 5. 1 by 3 is 3. 1 by 3 is 3. So that is multiplying by the 1. We're going to multiply by 5 now. But there's 1 0 sorry, there's one digit after the 5, so we're going to place 1 0, and then we're going to start to multiply. 5 by 8 is 40. So we cross that, put the 0 there. 5 by 5 is 25, and 4, 29. So we cross the 9 and put it there. 5 by 3 is 15, and 2, 17. So you cross the 7, put it there. 5 by 3 is 15, and 1, 16. Right? So you'll get 167900 there. What's the next one now? We're going to multiply by the 6. So this 6 has nothing after it, so you place no digits, and you say 6 8s are 48. Cross the 8, put it there. 6 5s are 30, and 4, 34. Cross the 4, put it here. 6 3s are 18, and 3, 21. Cross the 1, put it here. 6 3s are 18, and 2 is 20. All right, so we finished multiplying here, so we're going to come below here now and add. 8 and 0 is 8. That's 4. 9 and 1 is 10. And 8 is 18. Cross the 8, put it there. 7 and 5 is 12, and 1, 13. 6, 7, 8, 9, 10, 11, and 1, 12. Cross the 2, put it there. 3 and 1 is 4, and 1 is 5. Okay? But then, where do we put the decimal points? You check it from on top. So you start off at this position, and then you check from on top. There are 4 in the first 4 decimal places in the first figure, and 2 in the second one. So that is 4 and 2, 6 in all. So we have to move this 6 places. So 1, 2, 3, 4, 5, 6. So the answer for this one here would be 0.523848. And that's what comes across here. 0.523848. All right, so we reach a point now where we're going to combine two numbers whose signs are different, because this is positive here, but there's no multiplication or division present. So what do we do? What do we do? Very good. Take the smaller number from the larger number and keep the sign of the larger number. So we do 0.523848, 523848, and we're going to take away from that 0.125. And whatever result we get here, we're going to keep the sign of the larger number, which is negative, because 0.5238, this is larger than 0.125. So we're going to keep that sign when we finish do the subtraction. Okay? So let's do the subtraction. 0.523848, and we're going to subtract from it 0.125. Okay? Wherever we have spaces, we'll put zeros to make up the spaces. So let's subtract 0 from 8 is 8, 0 from 4 is 4, 0 from 8 is 8, 5 from 3 cannot, you borrow from the 2. So that becomes 1, and this becomes 13. 5 from 13 is 8. 2 from 1 cannot, borrow from the 5, you get 4. Carry the 1. 2 from 11 is 9. 1 from 4 is 3. So you get 0.398848 as the answer there. 398848. Right? So your final answer here will be negative 0.398848. That'll be a final answer. 0.398848. 0.39884 8848. Okay. All right, so that's how you would go about doing a problem of that type in terms of mixed operations, where you get a little bit of everything there. You get multiplication, subtraction, everything in order right there. Okay, so we're looking at approximations next. That's the heading, so write up approximations. And the first area we're looking at is rounding to a particular number of decimal places. So you could write that, rounding to a particular number of decimal places. Rounding to a particular number of decimal places. Okay, and the procedure is, your procedure is check from the decimal point, check from the decimal point to the right, check from the decimal point to the right, until you reach the number of decimal places required. Check from the decimal point to the right until you reach the number of decimal places required. Full stop. Increase this figure by 1. Increase this figure by 1, comma, increase this figure by 1, comma, only if the value of the next number, only if the value of the next number to the right, only if the value of the next number to the right is 5 or more. Okay, so if we have to round off 22.56902 to 1 decimal place, and we follow the procedure, you say check from the decimal point to the right. So we're checking from this decimal point here, and we're moving to the right. How many ever decimal places we're interested in? So if you go in 1 decimal place, all right, correct to 1 decimal place, you look 1 decimal place to the right. So this will be 22.5. Write that down, 22 point, and you would be tempted to write 5, but you don't write 5 just yet. You look at the number right next to the 5, which is 6. And that number is 5 or more. It's 6. It's greater than 5. So therefore, where we would be stopping, which is the 22.5, that 5 has to go up by 1 more. So that goes up to 22.6. That goes up to 22.6. Okay, let's look at 0.0199 next. Let's look at 0.0199 next. And if we had to round off 0.0199 to one decimal place, we do the same thing. We start at the decimal place, which is the point here, and we go one place to the left, which is we look at the 0. So we write down 0.0, but we have to investigate if that 0 has to go up or not. And we look at the 1 which is right next to it. We're going to look at this one here. But if that figure is not 5 or more, then the 0 would not change. And it isn't, it's 1. So that 0 remains as 0 here. So the answer is 0.0. Alright, so based on that, try to figure out the others for this top number and for the bottom number. Try and see what you'd get for 2 decimal places here and here, and 3. And then do the same thing for the bottom number. See what you come up with. Okay, so for the 2 decimal places, which is here, on this number, you should have gotten 22.57, right? And for 3 decimal places, 22.569. This one, 2 decimal places, 0.02. And 3 decimal places, 0.020. Okay, which one you like to have explained? This last one here. Okay, good, no problem. So let's explain it here. If we start off with 0.0199 and we go into 3 decimal places, which means we're looking at 1, 2, 3. But we can't stop here. We have to look at the number right next to it, which is a 9. This 9 is going to cause the other 9 before it to go 1 up, which is how much? 10. But in a single digit column, you cannot write 10, can you? So what you have to do is write 0 and carry the 1 from the 10 onto this one next to it. So 1 and 1 make 2. This 0 remains 0.0. You want me to say it again, or you're good there? Good? So that's how we ended up with 0.020 across here. Okay, so after decimal places, the next thing we're looking at is significant figures. So your heading is significant figures. Your heading would be significant figures. Okay, so the rule for significant figures is check numbers from left to right. Check numbers from left to right. Comma. The first significant figure is the first number, the first significant figure is the first number that is not 0. That is not 0. Open brackets, 0 can never be the first significant figure. Yeah. I'll start over. Check numbers from left to right, comma. The first significant figure is the first number that is not 0. The first significant figure is the first number that is not 0. Open brackets, 0 can never be the first significant figure. Close brackets. Thereafter, any number. Thereafter, any number. Thereafter, any number. Open brackets, including 0. Thereafter, any number. Open brackets, including 0. Close brackets, can be a significant figure. Can be a significant figure. Full stop. When you reach the number of significant figures, when you reach the number of significant figures, when you reach the number of significant figures required, increase the value of the last digit. Increase the value of the last digit by 1. Increase the value of the last digit by 1 only if the next digit to the right. Increase the value of the last digit by 1 only if the next one to the right is 5 or more. So we look at 105.8054. Right, 105.8054. And we're going to do six significant figures. 5, 4, 3, 2, and 1. Okay, that's what we're looking at. Okay. So if we're doing significant figures here, we start counting from the leftmost figure, and we move into the right, and we check in 6 figures. So this is 1, 2, 3, 4, 5, 6. So we write down 105.805. That is 1, 2, 3, 4, 5, 6. But then we have to determine if to leave it as 5 or if to carry it up. So we look at the number next to it, which is 4. But 4 is less than 5, so therefore this 5 remains. So the answer is 105.805, as shown there. 105.805, as shown here. Okay? 5 significant figures, 105.8, what should we put here? 1, because the 5 will cause the 0 to go up by 1. Okay, so 105.81 would be the answer for 5 significant figures. So you all work out for me now what 4 and 3 would be. Don't work out 2 just yet. Work out what 4 significant figures would be for me and 3. And then stop there, because you have some extra notes to put in for 2 significant figures. Okay, so for 4 significant figures, you should have 105.8. And for 3 significant, you should have 106. Okay? Okay, so now we're going on to 2 significant figures. So I want you, before we do that, to write 2 notes, 2 special notes. The first one is that always maintain the same amount of whole number digits. That's the first one you're looking at. Always maintain the same number, or same amount, sorry, of whole number digits. Always maintain the same amount of whole number digits. And below that you write, fill empty spaces with zeros. Fill empty spaces with zeros. Fill empty spaces with zeros. Okay, so what do we mean by that? Let's look at 2 significant figures in this situation here. So if we come back and we look at 105.8054, and we want to bring it to 2 significant figures, approximate it to 2 significant figures, we start off by writing 1, and right after 1 we write 0. Or we attempted to write 0, but before we write the 0, we observe that there's a 5 next to it. So that means that the 0 will round up to 1. So you write 11. So we may be tempted to write 11 as the answer. But the first thing we have to appreciate is that this is an approximation, and 11 is a very bad approximation of 105. So it means that something is not quite right. So we go to our special notes, and the note says that we must always have the same number of whole number digits that we started off with. So here we only have 2, and up here we have 3 whole number digits. So therefore, we need to have 3 in the end, and the second part of your note said to fill the missing spaces or the empty spaces with zeros. So therefore, the answer will be 110, and that will be to 2 significant figures. And you'll appreciate that 110 is a much closer approximation to 105 than 11 was. So that will always give you a guideline as to what you should put there. Okay? And you guys now tell me what the answer should be for 1 significant figure. What should the answer be for 1 significant figure? $100. Let's see. You put 1, because that's the first significant, 1. And then you look at the number next to it, which is 0, so it has no effect on it to carry it up or down. It leaves it at 1. And therefore, we have 2 spaces to fill, because we must end up with 3 digits. That's what we started out with, 3 whole number digits. So we have to put back the 2 zeros. 1, 2. So the answer, therefore, is 100. The answer is 100. Okay, so having looked at a large number, let's look at a decimal and see what we come up with. Let's say we had to look at 0.0058 0701 6 00580701 6, right? That's what we're looking at. If we had to do this to 6 significant figures, tell me, let's see if I'm going right. This would be 1. Correct? Why not? Well, all means 0 is not a value, that's a number. Look, 0 is a number here and we counted it there. What's wrong? Right, that's it. 0 could never be your first significant figure. So I can't count this here. So even though I write it, I can't count it as a significant figure. What about the next one? This one. Can we count it? No, because 0 could never be a first significant figure. This one neither. But we could start to count from the 5. So how much significant figures we have up to this point? 1, which is the 5. 2, 3. Can we count this? How come? Right, because it's not the first significant figure. So we could start to count it now. So we have 1, 2, 3, 4, 5, 6. And you'll be tempted to write 1 here, not so? But you have to look at the number right after it, which is the 6, and that's 5 or more. So we take off that 1, and we put in what it's supposed to be. It's supposed to be what? 2. Okay? For 5 significant figures, it'll be 0.0012345, because this 2 doesn't affect the 0. Okay, write down the rest there for me now. Write down the rest for me. Okay, so all of the answers are written down there. 4 significant figures, 3, 2, and 1. Any questions on those? All right, so finish with significant figures. And the last one we look at in terms of approximation is something called standard form. Okay, so your next heading is standard form or scientific notation. Sorry? Which piece? Here? Here? Why we didn't put a 0? Okay, because 2 significant figures would be the 5 and the 8. Those are the 2. Right? So these are not counted. This 0 is not counted. This one, nor this one. But this is counted. The 5 and the 8 is counted. So those are the 2. 1, 2. So that's it. You don't need to write anymore. Okay? Okay, so we're going to do standard form or scientific notation is the heading. Yeah, under approximations, the next one we're looking at is standard form or scientific notation. Okay, so standard form or scientific notation is the form A multiplied by 10 to the power of B. A multiplied by 10 to the power of B, where A is a number between 1 and 10. A is a number between 1 and 10, including 1, but not 10. Okay? And B is an integer. B is an integer. What is an integer? An integer is a number that is 0, 1, 2, 3, etc. Or it could even be negative, like -1, -2, and so on, going in the opposite direction. Okay? So B is an integer. So if we have an example, and we want to express the following in standard form. Express the following in standard form, and let's put to two significant figures. Express the following in standard form to two significant figures. That's what we're going to do. All right, and the number, for example, the first one is 2875 and 4 zeros. The next one is 0.00127, and the other one is 8.3. Okay, so these are the three numbers we're going to do in standard form. Okay? In order to arrive at A, right, remember it's A by 10 to the power of B is our standard form. In order to arrive at A, what we do is we look at where the point is located. In this number, it's right at the end. And we move that point in such a manner so as to create A. So let's see what that means. Let's move this point. That's 1, 2, 3, 4, 5, 6, 7. If I move that point 7 places to the left, you realize that I create this number. 2.875 and 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Right? By moving this how many places? 1, 2, 3, 4, 5, 6, 7 places. So I would have been able to create the first number A by moving this decimal place 7 places to the left. I would have created 2.875 and these zeros here. Now this 2.875 is satisfying our conditions for A, because we said that A is a number between 1 and 10, including 1 but not 10. So this is satisfying our A. And because we move it 7 places to the left, this would be equivalent to multiplying by 10 to the power of 7. Because if we did if we did expand this number back by multiplying by 10 to the 7, all we'd have to do is move this 7 places again and you'd get back the original number. Okay? So this could be expressed as this. The only thing is that even though it's in standard form, it's not to two significant figures. In order to bring it to two significant figures, this first number a would have to be adjusted and it will be to two significant figures, it will be 2.9. Right? Because 2 will be the first, 8 will be the second, but then of course you look at the 7 on the right of it, and if seen that this is 5 or more, this 8 goes up to 1, by 1 to 9. So more correctly, be 2.9 by 10 to the power of 7 will be an answer to two significant figures. Okay? So what I'll do, I'll put one right next to it here for you to look at. We had 2875. I'll put one here for you. Try this one now. Try 891500. 891500. Express that in standard form to two significant figures and tell me what you get. Okay, so for this one here, 891500, you would get in standard form, you'd have to move the decimal place 1, 2, 3, 4, 5 places. So it would be 8.91500 by 10 to the power of how much? 5, because you have to move it 5 places, so 5. But we needed to two significant figures. So really, to two significant figures, it'll be 8.912. This one has no effect on it. So it remains as 8.9 by 10 to the power of 5. 8.9 by 10 to the power of 5. In this case here, it's a little different. In this case here, it's a little different because it's a decimal fraction. Right? This was a large number. This is a decimal fraction. So in this case, in order to create our A value, we have to move this decimal point to the right now instead of the left. So we'll have to move it how many places? 1, 2, 3. Because if you notice, if I move it 3 places, I'll get 1.27, which is what I'm looking for A. Because that will be between 1 and 10. So you see, I have 1.27. And the number of places I moved it was how much? 3 places. 1, 2, 3. But the difference here is that because it's moving to the right and because it's a decimal fraction, this would have to be negative. So the answer is 1.27 by 10 to the minus 3. However, is that the two significant figures? It's not. So we have to fix this. So to two significant figures, it will be 1.3. Because the 2 is affected by the 7 by 10 to the power of minus 3. So 1.3 by 10 to the minus 3 is the answer. All right, I'm putting one here for you to try. A little tricky one. Okay, so express that one, 0.0199. Express that for me as standard form to two significant figures. In standard form to two significant figures. In this case, we have to move the decimal 1, 2 places. So it will be 1.99 by 10 to the power of 2. But because you're moving to the right and it's a decimal fraction, that will be minus 2. Okay? But this is not the two significant figures. So the two significant figures, this will be what? It will be 1, 2, 1, 2. But remember, this 9 will affect this. So what this 9 will become is 10, but you can't write 10 in a single digit. One has to carry over, so it will become 2.0 by 10 to the minus 2. 2.0 by 10 to the minus 2 would be the answer for this one. Okay? And I'd like you all to try part C now for me on your own. Give me a best shot for number C. It's a little different, so think a little bit before you write the answer. It's a little tricky. Okay, so this one was a little tricky because if you notice, in standard form, A, which is the first number, is between 1 and 10. Is 8.3 between 1 and 10? So it's already in the format of A. So in order to solve this one, all we do is we write it back, 8.3. We have to multiply it by 10 to some power. How many places did I have to move this decimal point so that I was able to get A? How many? None. Okay? And what is interesting to note is 10 to the power of 0 is 1. So if you were able, if you knew how to put it in your calculator, which you'll learn a little later on, and you put 10 to the power of 0, you'll work out to be 1. And 1 times 8.3 will give you back 8.3. So this is the answer here. 8.3 by 10 to the power of 0. Okay? So that's the answer for that one. And also, what is significant here is that the 8.3 is also to two significant figures already because it's just two figures in the number. Okay? The next thing that we look at tonight briefly is linear equations. Linear equations. That's what we look at briefly tonight. We won't go too much in depth in it. Linear equations. Okay, and the first thing first thing that we'll be looking at is what exactly is an equation. So you're going to write down what an equation is now. An equation is a mathematical statement. An equation is a mathematical statement that uses an equal sign. An equation is a mathematical statement that uses an equal sign. The next note is what a linear equation is. So you skip a line and you write in what a linear equation is. A linear equation is one of the form ax plus b is equal to c. The form is ax plus b is equal to c, where a, comma, b, where a, comma, b, and c are real numbers, where a, comma, b, and c are real numbers, and x is the unknown value. And x is the unknown value. Right? Some examples of linear equations would be 2x plus 5 is equal to 4. Another example might be minus 3x minus 5 is equal to 2. That's another example of a linear equation. Or 8x plus 7 is equal to 0. All these are examples of linear equations because they have a value for a in front of x, there's a value of b, and then there's a value of c. Right? All of those are linear equations. Now what we're going to do now briefly is to look at the solution of linear equations with one unknown. Right? We're going to look at that. So you could write that as your heading, solution of linear equations with one unknown. Okay, so let's say we had this equation x plus 2 equal to 7. And we were asked to solve this. Now, if we are asked to solve this linear equation, what it means is find the value of x that when placed in this equation makes the left-hand side of the equation equal to the right-hand side. Now, I'm sure that you guys could just watch that and tell me what value do I have to substitute for x here? Take out x and put a number. What number do I have to put here that both become equal? 5. How you all got 5? 5 and 2 is 7. But how you got the 5? Right, 7 take away 2 to give me what I have to put here. Right? But you did it so quickly, you know, you had the method there. Now, in the past, your teachers, just like my teachers, an easy way to teach a simple one like this is you carry this number over on the other side and change the sign. I'm sure almost everybody heard that statement already. But that statement in the long run in solution of equation leads to problems. And I'll just show you a quick example. If somebody gave me this question, minus 2 multiplied by x is equal to 20. Okay? And I were to use the philosophy of carry the minus 2 over onto the next side and change the sign. Right? That could have several interpretations. For example, if I carry the minus 2 over on the next side, I could write x would be equal to 20 plus 2. Because I carry the minus 2 on the next side and I change the sign. Right? Some of you may know that that is totally wrong. That's the wrong way to do it. Or somebody might say, well, so this minus 2 really means minus 2 multiplied by x equal to 20. So what you really want to do is to carry the minus 2 and change this sign. Right? So it could mean x is equal to 20 divided by minus 2. But then somebody might say, but you say change the sign. So you know what? That minus 2 had to be changed to plus 2. You understand? So they have several interpretations or carry it over and change the sign. So that's why it's important to really know what is going on. And that's why I'm going to make the attempt to show you, right, what is going on really. And one of the ways that they break it down is to use a scale, first of all, to represent something that is happening that we need to be aware of. So I'm trying to draw a little scale here, right, as a scale. And let's say this scale represents an equality, an equation. In this scale, we have 4 blocks on the left and 4 blocks on the right. Okay? If I were to add a block here, what would happen to that scale? It would tip over onto the left-hand side. So this would actually go down like this, right? And this side would go up, which means that it will be out of balance. That equality will no longer be there. So how do I fix that? If I add a block here and it becomes unequal, what do I have to do to fix it? Add a block on the other side like this. And similarly, if I take out a block on the left-hand side, to balance it back, what would I have to do on the right-hand side? Take out the block. So in other words, to maintain equality, whatever I do on one side, I must repeat that same operation on the other side. This is equality. So now, if we want to solve this equation, we're going to apply certain principles, including what we just learned there. And one of the principles is this. If I want to get x and find out what x is It means then that I have to remove this plus 2 to get what x is. Now, what is the opposite of plus 2? Minus 2. That is known as the additive inverse. The opposite of plus 2 is minus 2. Now, what that will effectively do on the left-hand side is this. Plus 2 will cancel out with minus 2. And I'll end up with x. Good? But remember what we just learned about equality. If I minus 2 on the left-hand side of the scale, what do I have to do on the right-hand side? Minus 2 as well. Not so? So we minus 2. That's what you did, but you didn't understand why you did it. Now you see why you're doing it. So you get x is equal to 5, which is what you just learned. Now, if you observe there's no such thing in our discussion here as carryover. We're talking about simple principles of balancing an equation and getting back to what x is. Okay? So that is the first example we look at. You could quickly jot it down. Okay, so I wrote down x minus 3 equal to 8 as another example. We're only doing 4 examples tonight and then we close off. X minus 3 equal to 8 is our another example. And in this case, if we want to obtain x, we have to do the opposite of minusing 3. What is the opposite of minus 3? Plus 3. So let's plus 3 here. Like this. And we learned that if we plus 3 on one side to maintain equality, which would have shifted by plus any 3, what we have to do here? Plus 3 as well. Remember, whatever you do on one side, you must do it on the other side to bring it back to equality, which is what this is. So the minus 3 is going to cancel out with the plus 3, and we're going to get x is equal to 11. So that's the solution for this one. X is equal to 11. Okay, the next example is 5x is equal to 35. In this case, this really means 5 multiplied by x is equal to 35. So if I want to get back x, I have to do the opposite of multiplying by 5. And the opposite of multiplying by 5 is what? Dividing by 5. So I'm going to divide this side by 5. And therefore, to maintain equality, what do I have to do on that side? Divide by 5 as well. So 5 into 5, 1, 5 into 5, 1. So I end up with x on this side, which is exactly what I want to find. And I say 35 divided by 5 is 7. So your answer here is x is equal to 7. So far, so good, right? Right. Okay, the last example for the night, I will show you two methods to solve it. The question is x over 6 is equal to 5. X over 6 is equal to 5. So if x over 6 is equal to 5, we observe that x is being divided by 6. What is the opposite of dividing by 6? Multiply. So x over 6 multiply by 6. What must we do on the other side? Multiply by 6 as well. Because whatever we do on this side, we have to repeat it here to balance it back all the time. So this 6 in a 6, 1, 6 in a 6, 1. You get x by 1 is x over 1. So we get x on top is equal to 5 by 6, which is 30. So x equal to 30. X equal to 30. And there's another way to do it, right, which a lot of people default to. And we were talking about this method before, but without really knowing what we were talking about. So I'll write it back here. X over 6 is equal to 5. Okay, so we're going to look at x over 6 equal to 5. This method we're going to use is called cross multiplication. Remember we were speaking about it before, but it was really in the context. This is the context for cross multiplication. So what you do is you recognize that there's a fraction, an equal sign. If you put this number over 1 like this, then this is a good candidate for cross multiplication, where you multiply the top number on one side by the bottom number on the other side. So we write 5 multiplied by 6 is equal to, you do the same thing here. Top number multiplied by bottom number. X multiplied by 1. So 5 by 6 is x multiplied by 1. 5 by 6 is 30. X by 1 is x. So 30 equal to x, or x is equal to 30. Which is, if you observe, this answer is the same thing as this answer. So both methods work perfectly well. Okay, your homework assignment is exercise 17 to 21. Exercise 17 to 21. And exercise 22, numbers 1 to 5. Okay, and that will be in your certificate maths book, in certificate mathematics. Okay, so that will be it for tonight. I hope you guys had a good class. You learned something. Enjoy.